Okay, now we have just gone through how the transformer is looking like, what is the core of transformer, what are the windings in transformer, okay, what are the general conventions of transformer. I call it as the vectors. I told you V1, then I1, then phi1, then let us see in some cases the instantaneous power P1 also, or we call it as the operant power S1 on this primary side. On secondary side, what is happening? It is V2, I2, phi2, P2 and S2. What is this S? S is having both the powers, right? Let us say here Q1 and Q2. What is S1? S1 is P1 plus J times Q1. What is S2? S2 equal to P2 plus J times Q. Please remember, all these quantities are time dependent quantities. I am writing the instantaneous values. Okay. Now what is see now I told you that all these quantities are instantaneous quantities. All these quantities are time dependent quantities. All these quantities are trigonometric quantities. Because nothing in this universe is of scalar nature. It is, everything is time dependent. Okay. Now what is happening? I will try to find out what are the angles between these two. What is the angle between V1 and V2? Let us try to get. Suppose there is a transformer. Normally the symbol of transformer is drawn like this. Okay, I am just drawing it. Just these are the two lines. Two lines are defining the core of transformer. This is symbol. Okay. Need not be always we need to draw that square and that core type transformer. This is the primary winding, this is secondary winding, this is core. Now here I can give, suppose I am giving the waveform like this, and the waveform is of instantaneous V1. Now what will be the waveform on other side, on transformer secondary? I need to find it out. Now actually mathematically we can prove that on this side the waveform generated will be of like this V2. But practically how to find it out, how to get the waveforms. Now suppose I want to define the vector. How I will define? If you look from the top, you will find that it is looking like a dot. If you look it from this side, you will find it is a cross. Normally any vector is defined as dot and cross. Suppose I am giving the dot on this side, whether the dot will come on this side or that side, I need to find out. And for that purpose I need to find out the polarity of transformer. It is called as polarity. Finding out the direction of induced EMF on the other side of transformer. Now how I will do? I can just connect these two windings. Now before that, let us try to get it clear. On this side the number of turns are small. Let us say 50 turns. On this side number of turns are, let us say 100 turns. Whenever number of turns are more, what will happen to the voltage? I need to find it out. Okay. On this side, as the number of turns are less, what will be the size of this winding? I mean there are two different wires. One is of bigger diameter, one is of small diameter. Which one will be the high voltage winding and which one will be the low voltage winding? I need to find out for any unknown transformer what is the high voltage and low voltage winding. Because it is unknown to me, what I will do? I will just apply here voltage. The application of voltage can be anything. Let us try to draw something, auto transformer here. I am applying. This is voltage V on this supply side, and here it is V1. Now suppose I make it at this point the voltage applied to the winding is 0. I will just increase the voltage. If I give here test voltage called as 10 volts, I will just measure on this side what is the voltage. Voltage V2. Suppose I am getting here 20 volts. Then it is called as step-up transformer because the voltage has been increased from 10 volts to 20 volts. Suppose it means I can say that this is the high voltage winding. Okay, it is high voltage winding. And this is the low voltage winding. It means first of all I need to find out which winding is of how much voltage, whether it is high voltage winding or low voltage winding. And for that purpose, simply I have done a simple experiment. I have applied the test voltage of 10 volts and see what is happening on the other side, measure the voltage. Now voltage measured here is of RMS value. Well, okay, all meters are measuring the RMS values in case of AC supply. Here also this is the RMS value. If I am measuring the RMS value on this side, okay, magnitude is okay. I am getting the magnitude on that side as 20 volts. But I don't know what is the direction of that magnitude. And that direction of magnitude can be found out by a simple experiment again. Just connect this point. That is secondary, primary side, second point is connected to the secondary side. It is called possible to connect it because they are connected in series only now. Let us see. Now connect this voltmeter from this point to this point. Now what is happening? If I am applying here 10 volts, 20 volts are getting on secondary side, and if these windings are connected together, the diagram looks like this. Okay, here I am applying 10 volts, here it is 20 volts. Now I am just measuring the voltage across this winding. And of course this is again RMS only. If I am getting here 30 volts, then I can say that the dots are like this, because dots are getting added. It means the direction of both the windings can be established. Anything can be established by comparing to the first one. Now if these two windings are connected together, see, or it is possible that the dots may be at this point also. Only the thing is, I am finding out the dots on both the sides, whether they are at proper point. It means I am saying that, let us first of all assume just that the dots are here. First dot is here, another is here. I am just assume because I am getting 30 volts in the voltmeter. Okay, here it is 10 volts, here it is 20 volts. Now what is happening? It means I have just established that this is the dot on this side, primary side. On other side, this is the dot. Okay, because it is connected there. See this direction. It means if the dot or if the positive of the wave cycle is coming at this point, the same positive cycle will come at this point. Of course, depending on the amplitude. Now it is 20 volts, amplitude is higher, let us say it is higher with respect to this one. It means at any instant of time, the positive portion on this primary side will come here, not here. Here it will be a reverse waveform because it is the downward direction. It means I have established the phasors as in this direction and other phasor is in this direction. Okay, suppose you are not getting like this. Suppose I am getting here the answer as 10 volts. Then what is the meaning? The meaning is the dots are in opposite direction. It is like this. They are in opposite direction. If I add it together, you will find that 20 minus 10 is 10 volts. In that case, the polarity would be at different point. It may not be at this point, but here, these are the polarities. Normally in transformer, in general convention, it is said that polarities or dots are always in cross. Dots are in cross. Normally, dots are in cross. It means this is the normal convention. If I am getting such type of vectors, it means at any instant, suppose the positive cycle is coming here, the positive cycle will come here, not here. Now I can establish a phasor diagram of this. You can take a screenshot if it is required. I hope you have taken the screenshot. We will try to establish the vector diagram generally in these conventions as we are continuing to talk. Okay. Now I told you I am applying the voltage V1. Now let us try to find out. V1 suppose is in this direction. Now I have defined the direction, that's why I can write V1 like this. It need not be now instantaneous V1 because it is already having direction. As soon as I am applying the voltage V1, I told you it is inductive circuit. Okay. If I am applying V1 in this direction, the current will start flowing, and I call this current as I0 because the transformer is on no load. Now whenever the current starts flowing, you will find that this current and this voltage are having some angle difference, and that angle difference is because of impedance of this winding. Now impedance of this winding is Z1, okay, and the angle must be phi0. Phi0 means it is the no load angle, or this current I0 will be at an angle phi0. So I will just draw this current I0. I am drawing this current at an angle phi0 lagging by some angle because it is an inductive circuit. It cannot be on this side, it has to be on this side. Okay. Now as soon as there is flow of current I0, it will establish the flux. I call that flux as phi. It will establish the flux depending on the reluctance of the circuit. How much is the magnetic opposition to the flow, and that's why I draw it by with some angle. Okay. This flux, and you will find that this current I0 is having two components. One is called as the magnetizing component, and another is called as the working component, because it is having some angle, and magnetizing component Iv is defined as I0 sin phi 0, and Iw is defined as I0 cos phi 0. Now, normally the responsible component for the flow of flux or establishment of flux is the sign component of the magnetizing current, and this working component Iw is actually required to supply the losses within the transformer. Normally the losses associated with are the core losses. Okay, I will not go into that detail. We can cover it in next lecture. But at this moment, as the flux is established, I call it as phi m, and this flux is there in the core. Okay, I hope you can imagine and recall the winding is there. This core is having this current, this flux phi m. Because of this phi m, there is establishment of voltage V2 on this side. I can call, normally V1 and E1 are of same magnitude because there is a little difference there. E2. Voltage is established on the secondary side. If I load the secondary side, the current will start flowing. I call it as I2 current. We are seeing in previous lecture. This I2 current is flowing with some angle of secondary side impedance. I call it as phi 2. Here, now I need to, as this current is flowing from secondary side, it is affecting the flux within this, and because of that, the primary current, which was I0, is getting converted into I1 now, because the I2 will try to disturb the I0, or it will try to increase the I0, and in that case I need to get this I2 on this side. I am just getting this dotted one, okay? Because I want to add the phasors of I0 and I2. This is, I call it as I2 dash. The current reflected on primary side. This is the primary side of transformer, this is secondary side of transformer. Now, if I want to add these two currents, you will find that I can add it like this. This current is I1. Now, I1 is having a little change in angle. I call the angle as phi 1. In some case, it is called as phi. Phi 2 is the secondary power factor angle with respect to voltage V2, and phi 1 is this is the power factor angle on primary side, on this side. Okay. Now, this is the general vector diagram of the transformer on loading. I have not changed the voltage V2, only it is the flow of current. We can modify this diagram depending on the requirement. Thank you.